So good morning to you all, and so I am going to start the third lecture on extrusion technology. Hope today you are okay because today no power cut according to the CEB. So hopefully we can do the lecture, conduct the lecture continuously for around 1 hour. So last week we have discussed about the functions of the extruders and basic parts, right? Extruder types, what type of extruders are available in the industries. Those things we have discussed, right? Instead of that, the difference in between cold and hot extrusion, what are the differences in between these two methods? So, when it comes to hot extrusion, so the temperature is little higher than the room or environment temperature, and somewhat around 100 degrees of Celsius, like the higher temperatures. But cold extrusion means we use somewhat around room temperature. It is 737, 40, like so for some sensitive food products. So as an example, so if we are going to secure the nutrition value of such food and we don't to have much temperature, so we can use cold extruders. So as an example, we use cold extruders for in developing pasta like food products, and hot extruders for tip like snacks, puff snacks. So I hope that you all know these things and you're aware about the extrusions. And when you go to the market now, you can identify the extruded products, and you can determine the extruder they have used to develop this food product. Hopefully, we can go ahead with this knowledge, general knowledge, and at the end of the day, we can design extruder and we can develop our own food products also. And important parts of an extruder, this is very important. So we have discussed some technical terms, and you know what is flight height. So what is a helix angle? You know these things, and what is the die? All these things. And what is the difference in between root diameter and the barrel diameter, right? So these things we have discussed last week, right? So with this knowledge, so we can go ahead. Today we are going to discuss about extruder dies. So you know it is one of the very important parts of an extruder. So die is actually the very critical part. So so you know what is, when we go back to the first lecture, we have discussed the definition. So what is food extrusion? So under this definition, we have discussed extrusion is just a novel food processing technology. It is not actually a novel one, but for Sri Lanka, it is somewhat novel one. And we forced food material under pressure and get a food product or finished product through a die, right? So die is very important. We all have this experience in our when we are preparing string hoppers in our home or muruku. So we use the Wangediya string hopper maker. So there is a die at the end of the Wangediya. You can say die. අපි හැමෝම දැකලා තියෙන දියාපු වංගෙඩියේ යට තියෙනවා මෙටල් පාර්ට් එකක්. ඒකේ සිදුරු ඕගොල්ලෝ සාමාන්‍යයෙන් අපි ගන්නෙ ගෙදර පොඩි ටින් එකක් කපලා අරගෙන ඒකේ සිදුරු ඉදලත් ගන්නවා. So that is a die, and we have experienced, right? අපි experience කරලා තියෙනවා. අපි high pressure කරොත්, if we pressure the gadget to devices, then what happens? Sometimes the dies will break. නේද? die එක ගලවලා බිමට වැටෙනවා. නැත්නම් ඒකේ holes ලොකු වෙනවා. Because it is the metal hardness is not enough to absorb the pressure we apply. අපි යොදන pressure එක apply කරගන්න බෑ. හරි? In the extruders also we have a die. So you can see the die here. At the end of the extruder you can see the die. එතකොට සාමාන්‍යයෙන් extruder එක අග තමයි die එක තියෙන්නේ. ඊට පස්සෙත් we have some gadgets. We call it as after extrusion, right? drying, salting, like there are some other processes. Here you can see the die. So there are so many types of dies are available, but I am going to discuss the general, going to discuss some general parts, right? So itra mitra tamai mein extrude ke screw ek, you can see the screw and the cone shape at the end of the screw. And here also you can see a cone shape, right? And there are two parts. It's a simple design, right? But here you can see some special channels. එතකොට අපි සාමාන්‍යයෙන් when we discuss about a syringe, අපි සාමාන්‍ය syringe එකක් ගත්තොත් එක output එකයි තියෙන්නේ. අපි වතුර ටිකක් දාලා ඔක press කරාම මේ පැත්තෙන් දෙකෙන් එනවා. අපි ඉන්දියාපු අංගෙඩියක් ගත්තත් we have one end, right? It's general, not complex. But here we can see several dies, several parts, channels are available. So and the specific designs are also there. As an example, you can see a cone shape end for the screw. And here also you can see some metal part, right? And we call as CS, screw and shaft cone. That's a technical term. CD, die cone entrance, right? DE, die assembly. So there are several other names are available. So these three are very important, right? Shaft cone එක තියෙනවා, die entrance එක තියෙනවා, assembly එක තියෙනවා. ඇයි අපිට මේවා ඕනේ? Right? Can somebody tell me why do we need these things? කාටද කියන්න පුළුවන්ද ඇයි මේ මොකටද මෙච්චර මහන්සිලා හදලා තියෙන්නේ? දැන් මෙතන සිලින්ඩර් එකම තියන්න තිබ්බනේ. ඇයි මේ කෝන් එකක් හදලා තියෙන්නේ? Huh? So there are some specific designs. For what? What's this? Huh? No answers. Good. So the ultimate objective of this design is to you know, the pressure is very high in this area. The extruder ගත්තාම pressure we ඇවිල්ලා end of the extruder, you know, the pressure is very high. And the pressure difference is also very high. දැන් මෙතනින් එළිය ගත්තොත් මේ extruder die එකෙන් එළිය ගත්තොත් pressure එක සාමාන්‍ය atmospheric pressure. වායුගෝලීය පීඩනය. Inside, you know, it's very high pressure. So you know the maintaining the pressure is very important. And sometimes when we feed the food materials from here to here, right here to here, if we don't have this cone, then what will happen? It is difficult to maintain the channel flow. The flow එක maintain කරන්න a little bit different. And also to maintain the proper pressure value here, it is also again very important to have this pressure, right? So these three things are very important to have in general food extruders. And cone shape we maintain to adhere to the pressure value in this extruder. Understood? So එතකොට මේ cone shape එක තියෙනයි කියලා you have to understand, right? And when you are designing extruder also, you have to think on these specific design. So what are the objectives of having these specific design, right? So and here you can see two channels. Not actually, no, there will be several channels, but here it is actually a diagram. So here is a 2D diagram. In this one, you can see two channels, but we'll see how many channels are there. So you know there are several channels in extruders, right? And one term is there, farinaceous and proteinaceous. So this is actually not relevant to this lecture. So but when I am referring some articles, I found these two words, right? One of the farinaceous and proteinaceous කියන්නේ. So do you have any idea? But you have to understand as you are doing food technology. So Okay, you have to search these two terms in Intreto books. You can use any material and come up with several examples. What are the farinaceous foods and what are the proteinaceous foods? Right. So I hope that you all get this point of extruded dyes, right? And in this diagram, you can see the same picture. I have used this diagram to explain that in some extruders, but as I told you earlier, some extruders we can see different types of dyes. Right here, you can see two channels and cones are there. The food material coming from here, from this end to this end, and the flow is there. Right. As a result of this pressure, we call it as, what is the word? Pressure. So we use a different word, right? Shear force. So as a result of the shear force, the food materials will move from here to the here to here. These are the two channels, and in some you can see here there are several channels. In some extruders, they have a common place, but there are several ends. So සමහර extruders වල තියෙනවා මෙහි ඉඳන්ම channels දෙකක් තුන channels දෙකක් නේ අතන ගොඩක් තියෙනවා මෙතන දෙකයි පෙන්නලා තියෙන්නේ. In මේ end එකේ ඉඳන්ම channels තියෙනවා. But some extruders they have, like we are doing string hopper making. So we don't have any specific design area. There is at the end of the cylinder you have a die there. So several places to out, right? The dough collect to the similar area, particular area. From this area storage, we are going to apply further pressure and extrude, right? ඒ කියන්නේ සමහර extruders වල මෙහි ඉඳන්ම channels වලින් කියනවා සමහර ඒ වගේ එක තැනකට ගෙනල්ලා ආයෙත් syringe එක වගේ press කරනවා එතකොට එතනින් යනවා, right? So based on our applications and the design and the fabrication technologies, we can see different shapes of dies, right? එතකොට අපේ requirement එකට ඕන එකක් තෝරගන්න ඕනේ. So we in twin screw extruders, right? Twin screw extruders, so the die shape is totally different. We are discussing about single screw extruders, so these are the designs. You can see some examples here. There are here only 3 dies, 3 holes, 3 outputs, but you can see at the end of here in this place some examples for food dies, food extruder dies. So you can see the shapes. Different shapes are available, right? And you can calculate the outputs. How many outputs? Here, as an example, 1, 2, 3, 4, 5, 6. 6 here. Again, different outputs are there. So you can get different products and outputs. So efficiency also different with the die. And there are 2 major functions of extruder die. So the pressure maintenance is very important as we discussed. එතකොට extruder die එකේ අපි එළියට ගන්න අපි සිදුරු කීපයක් තියෙනවා. සමහර ඒවා එකක් තියෙන්නත් පුළුවන්, ගොඩක් තියෙන්නත් පුළුවන්, බොහෝ වෙලාවට ගොඩක් තියෙනවා. right? එතකොට ඒ දෙකේ වෙනස ගත්තොතින් ඔයගොල්ලෝ දන්නවා pressure එක apply වෙන pressure එක වෙනස් වෙනවා. right? අපිට එක සැරයකට එළියට එන එක product එකක් නම් එක මෙතන 3යි එන්නේ. If we have a die with 6 outputs, so the pressure applied is little bit lower than this one නේද? එතකොට මීට වඩා die එක ටිකක් rigid අඩු වුණාට කමක් නැහැ. මොකද pressure එකට ඉක්මනට අඩු වෙනවා. right? If we have one output, so the pressure, and based on the diameter of the output, it is also dependent. Diameter එක මේකේ size එක everything are very important. So what are the functions of extruder die? So there are 2 major functions to develop and maintain the pressure. As a result of pressure, it gives a shape for the final product, right? So here you can understand it will provide a shape for a particular shape, right? Specific shape to the product and promote resistance to the material flow. you can see here how it promote the resistance. නේද? ඒතර කොහොමද මෙතන resistance එක අරගෙන තියෙන කියලා ඔයගොල්ලන්ට පේනවා මේ design එකේ. ඒතර die එකේදී based on the diameters of these channels and number of channels, right? The distance in between these two ends and the material, all these things are important. So what are the two major functions of extruder die? It will provide a shape and also retain the pressure, as it means basically promote the resistance, right? Also, dies have various designs and number of orifices. Dies are highly restrictive, right? Various designs තියෙනවා ඔයගොල්ලෝ දන්නවා. Orifices can සිදුරු කීපයක් තියෙන්න පුළුවන්, එකක් තියෙන්න පුළුවන්, right? So these are the important things to be remembered. And what are the other important things? So suppose you are going to design an extruder die. You have extruder, a small extruder you have developed in your home, right? So you are going to develop, you are going to prepare a die, right? As an example for these days, you know, the string hoppers, we have very good market for string hoppers. So you are going to develop a string hopper maker with by using extrusion technology. So at the end we should have dies, so you can develop different types of string hoppers, right? And you can use a similar machine for develop different products such as murukku, like different shape products. So our die has broken, so we are going to develop a new die, right? The pressure is a little bit lower, you know, when we are doing our home applications, though that is not industrial. The pressure is we can manage. So suppose you are going to develop the die using the materials available in your home. අපිට දැන් ගෙදර මොනවා හරි අපි එක්ස්ට්‍රූඩ් එකක් හදා ගන්න යනකොට අපිට ගෙදර තියෙන දේවල් වලින් ඩයි එක හදා ගන්න පුළුවන් ප්‍රෙෂර් එක අඩු නිසා shear force එක අඩුයි. එතකොට අපි ඔන්න ඇවිදගෙන යනකොට අපිට හම්බ වෙනවා සමන් ටින් එකක්. ඒ වගේ ටින් එකක් අපි අරගෙන ඩයි එකක් හදා ගන්න. So materials is very important. So we are not going to use cardboard, right? Aluminium, right? If you use aluminium, so you know what happened. In every morning there are oxides are there. We have this experience when we are traveling by bus. So we touch the bar. Then early morning when we are schooling, we can see oxides on our hands. අපි උදේ ඉස්කෝලේ යනකොට බස් එකේ අර එල්ලිලා උදේට ගියාම කළු පාට ඔක්සයිඩ්ස් තියෙනවා අපේ අතේ. නේ ඔයගොල්ලෝ අපි හැමෝටම එක්ස්පීරියන්ස් එක තියෙනවා. So we are not going to use aluminium like things because it's not good for food products. Sometimes you will have some toxic items in your home. ගෙදරට polish ගෙනාවු එකක්, clean ගෙනාවු tin එකක් තිබුණොත්, so we are not going to use that one also. Because that is toxic, because of food items directly touch with this dye. Okay? There is a heat, there is a pressure, there are food products, so it is a high risk one. So do not use, never use toxic material for dye. And in the other hand, some reactive materials are there. So when we use that type of materials, there are some reactions. So suppose we are going to develop a little bit acidic product. pH එක අඩු කරලා යනවා product එකක් හදන්න. එතකොට අපි කෙලවරට aluminium එකම දැම්මොත් මොකද වෙන්නේ? So you know by experience that is it will generate some toxics. So never use toxic materials, reactive materials, and the hardness also very important. Got it? Okay. And so we can go ahead now. You can see some other examples and diagrams I have taken from the internet. So what are the terms? So we have discussed general terms. There are some other terms. No, you need not to remember. And here you can see some dies with the actual food product. You can see both the die and the product. Here, die shape and the product shape, right? Okay. These things are very important. How to select die, you know how to select, how to select a die. The things we have to consider in selecting, and basically we use Teflon, right? We can use Teflon like materials in developing dies, and stainless steel is the recommended one, but the pressure is very high, so we are using commonly we are not using stainless steel, so they are using, but in our very low cost one we are not using. එතකොට අපි use කරනවා සමහරට චීන චට්ටි කියලා ඔයගොල්ලෝ අහලා ඇති. මේ වගේ materials අපි පාවිච්චි කරනවා. Right? But the recommended one are not should not be reacted. So therefore stainless steel is very good, and Teflon like materials also using commonly. So please write those things. So the examples are not available in this slide. So you can search some materials to be used in designing extruded die. ඔයගොල්ලන්ට experience තියෙනවා ඔයගොල්ලෝගේ ආයතන තියෙනවා හොයන්න මොනවද අපි පාවිච්චි කරන materials කියලා. Right, this is actually an exercise. I have this is also an interesting one. I have designed this picture and use very common example, very common equations. මේ නිකමට මේ picture එකක් ඇඳලා රූපයක් ඇඳලා මේ equation ටික දාලා බලපු එකක් මෙතන තියෙන්නේ කොහොමද මේකේ සම්බන්ධයක් හදාගන්නේ කියලා. You know these equations very common in your A levels and grade 5, grade 6. You may heard these equations. Perhaps you are studying these equations in your university. You should have food physics like subject or food engineering. Under those subjects, you should study these equations also, right? Q equals A multiplied by V. It is very important. Q means quantity. A means cross area. V is velocity, right? V1 equals P2 V2. That is also very general one. Pressure, volume, the how those pressure and volumes are, how to use, right? D equals M divided by V. D, you know, density. M mass. This should be a simple M, and V again velocity, right? Sorry, not volume, right? E equals half mv square. That's kinetic energy. Chalaka shakti ඔයගොල්ලෝ දන්නවා භාගය mv වර්ග. F equals P multiplied by A. P means pressure. A again cross area. So I have used these 5 equations and developed this relativity. So not relativity, this equation. This you can see here the diameter is RA. This here RB, and the pressure and the cross area A1, pressure PA, and velocity here V1, here V2. And you can see the food materials, how they are moving, right? Here in green, yellow color inside the extruder, and the red color inside the what do we call die, and this one in the environment. So my equation ටික පාවිච්චි කරලා මම මේ නිකන් හදපු සමීකරණයක් තියෙනවා. Can you hear me now? Are you there?
Yes, sir.
එතකොට ඔයගොල්ලන්ට මේක නිකන් home exercise එකක් විදිහට කරන්න බැරි වුණොත් I will explain, right? So I just wanted to calculate the pressure and the volume and the distance traveled. So you know, with the distance and the pressure, all things are different. So how to calculate these things, right? Let's discuss the next lecture. Right. So we are moving towards single screw extruders further, right? as we discussed, it's one of the most commonly used extruder in the food industry. And there are three major zones: conveying and compacting, melting and dough forming, and melt conveying, right? So we call it as solid conveying, transition, and metering, right? There are three zones. We can divide these zones based on the application and based on the extruder type. So the zones can also be different, right? So these are some examples. So sometimes you can see different classifications. So don't worry about these things. And the screw speed of the food extruders are higher than plastic extruders. So in developing plastic products, aluminium development and ferrous අපි යකඩ හදන්නෙත් extrude කළා ගොඩක් aluminium products හදන්නෙත් extrude කළා. There are so many videos available in YouTube, so you can search how aluminium develop and how metals are developed, how plastic developed by using extruders. But the important thing is screw speed is higher than plastic extruders in food processing extruders, right? Relatively small particles we use. So as we discussed, අපි කතා කරා මොන වගේ දේවල්ද පාවිච්චි කරන්න කියලා. Basically starch, flour, and some small crystals we use, and basically we are going to develop a dough. But in aluminium and plastic and other things, right, we use a little bit higher raw materials in this higher shapes. So what is the reason? To avoid the bridging problem that at the feed throat. So this is the feed throat. You can see the feed throat here, the feeder, right? Hopper, we call it as feeder. The feed throat. මෙතන සමහරලාට රැඳෙන්න පුළුවන්. You have this experience නේද? ඔයගොල්ලෝ සමහරලාට පුණීලකට අපි පිටි දැම්මොත් ඕගොල්ලන්ට තේරෙනවා. ලොකු දේවල් දැම්මොත් අවා ගන්න අමාරුයි. ඒතර feed throat එකේ රැඳෙනවා. Right? That's the simple thing. So to avoid this error consequence, we are using small particles in food extrusion, right? Okay, so now you know what is the die. What are these important things in designing dies? All these things, it's clear. And why are we using small particles in food extrusion? That is also clear, right? And what is the bridging problem? Is a very common term in extrusion. So you know what is the bridging. Now we are going to discuss about how the solid, the raw metals are moving towards the die, and what are the mechanisms and some engineering parts. So initially, just imagine that we are going to start the extruder. Right? In starting the extruder, suppose the capacity is around 10 kilograms. Extruder capacity is kilogram the high. So the first cup we are going to use. The first cup 1 kilogram. අපි දැන් extruder එක පටන් ගන්න යනවා. අපි මුලින්ම kilogram එකක් දානවා extruder එකට. Then what happened? It started. Extruder has started. The parts are moving. Screw is also moving. We have add 1 kilogram of raw material. Then it is start to move. Right? Initially, the ingredients conveyed in non-filled screw, similar to a plug flow. We call it as a plug flow by the drag action of the rotating screw. Right? We call it as a plug flow as a result of drag action of the rotating screw. So you know what the screw? Screw there are flights on the screw. Then we add some raw materials. The flights will drag those raw materials. So pressure එකක් develop වෙන්නේ නැහැනේ. නිකන් ඇදගෙන යන එක තමයි වෙන්නේ පළවෙනි ටික. Then we are going to add some 2 kilos, 3 kilos, 4 kilos. Then what happened? You know, enough adequate amount of raw metals are there. The barrel capacity is 10 kilograms. We have just add just think 8 kilograms. Right now, you know, a capacity is almost full, around more than 80% full. Then the moving speed and the pressure, all these things are different. Right? Then we are further adding, just imagine these things. හිතන්න දැන් කල්පනා කරන්න මම කියන්නේ මොකක්ද කියලා, right? අපි extrude එක on කරා. දැන් ඔයගොල්ලෝ මේ කැරගෙනවා screw එක. අපි කිලෝග්‍රෑම් එකක් දැම්මම 10ක් capacity එක තියෙන එකට එකක් දැම්මම දැනෙන්නේ නැහැ. දැන් නිකන් එක කැරකි පොඩ පොඩ එහාට යනවා plug flow එකේ හින්දා. ඇදගෙන යනවා අර screw solid. Then we are going to adding the continuously we are adding 1 kilogram further. Then now it's somewhat around 8 kilograms or more. Now you can think the raw metals are there inside. The cabin has almost full. Only 2 kilograms we can add. So we just add rest 2 kilograms. Now entirely the barrel is full. Right? Now we call it as solid bed. Then අපි එකට කියන්නේ solid bed එකක් කියලා. Right? Now the screw is moving again. Screw is actually moving continuously. Then what happened? So dragging action is there. Plug flow you can remember. Now solid bed is there. Now start to melt it. Melt the raw materials. So raw materials are melting, mixing, all these things are happening now. Pressure also develop. And with the time and the temperature, so you know there are some reactions. Agglomerization, you can remember. Gelatinization, you can remember. These things are also happening simultaneously, right? And there are some internal locking forces. So it means there are some internal forces in between two particles, right? අපි දන්නවා අර starch අපි පාවිච්චි කරන wheat flour වල ඒ particles අතර පොඩි පොඩි bonds තියෙනවා, right? So it is lower than applied shear stress. Now the pressure has been increased, right? Pressure has been increased up to some very high amount. So the bonds will break. Right? The bonds will break and start to gelatinize and mix those particles together. So there might be 2-3 ingredients, might be 5 ingredients. So we are going to add some wood, flavors, all these things. With these raw materials, they will mix together. Understood? තේරුණාද ඔයගොල්ලන්ට? ප්‍රශ්න දෙන අහන්න. දැන් මෙතනින් එහා ටිකක් complex හරි. Here you can see the solid bed, solid bed here. Plug flow, you can see here what happened when we are adding raw materials to the feed tank. So it will start to move, right? We call it a drag action due to this flight, right? අර ඔයගොල්ලෝ ගෙදර ඉන්නකොට අත් දෙක අල්ලගෙන ඉන්නේ දෙන්නෙක් කැම්පස් එකට ආවම ගොඩක් අය ඉන්නකොට අත් අල්ලන් ආපුවා අමතක වෙනවා නේ, right? That is also solid bed. One example for solid bed and drag action. ඇදගෙන කැම්පස් එකට එනවා ආවට පස්සේ ගෙදර යන්නේ නැහැ. And solid bed, you can see here compact solid bed, right? The characteristics of solid bed. So it means entirely filled, right? And drag flow, we have discussed drag flow, right? Now the screw is moving from here to here because screw output is there. The screw එක මේ පැත්තට තමයි යන්නේ. ඒතර ඔයගොල්ලෝ පේනවා flow එක තියෙන විදිය. ඊතල ටික තියෙන දකුණු පැත්තට. It means screw එක කරගෙන ඉතල මේ පැත්තට මෙහෙම. So as a result of this screw, flow is there. Pressure flow means now the entirely filled. It means solid bed is there. So එතකොට මේ පැත්ත තද කරනකොට මේ පැත්තනොත් pressure එකක් develop වෙනවා. So you can see the arrow sides from here to right to left. The flow is from left to right. The pressure flow is right to left. ඔයගොල්ලෝ දන්නවා ටිකක් සිරින්ජර් එකට අපි පැණි ටිකක් ප්‍රෙස් කරන්න කිව්වොත් මොකද වෙන්නේ? ඒක ප්‍රෙස් කරන්න බෑ. flow එක අතට එනවා. අතට දැනෙනවා pressure එක. And there is a term called leakage flow. Right? Leakage flow කියලාත් එකක් තියෙනවා. ඒතර leakage flow කියන්නේ so now the solid bed is there due to this compact structure. So you know pressure flow is there from to the right to left. As a result of this pressure, so some particles will move towards right to left. It means opposite side. Our the flow rate is from left to right. From here you can see the output direction here, but there is a flow called leakage flow from to the opposite side. You can see a small space here. එතකොට බැරල් එකයි ස්ක්‍රූ එක අතරේ පොඩි ස්පේස් එකක් තියෙන සමහර ඒ වගේ තියෙනවා. ඒතර ඒක තිබ්බොත් මොකද වෙන්නේ? මේ අතරින් මේ ප්‍රෙෂර් එක නිසා අනිත් පැත්තට මේ මැටීරියල්ස් ටික මූව් වෙන්න ගන්න. පොඩි ප්‍රමාණයක්. Right? So how to avoid that leakage flow? Any idea? රැක් කොහොමද දැන් නම් උනා හරි. ඔයගොල්ලෝ තේරෙනවද මම කියන එක නේද? මොනවා හරි. ග්‍රීක් වගේ නෑනේ තේරෙනවද නේද? කියන්න මොකද කියලා. දැන් මම අහන්නේ මේකේ ඩ්‍රැග් ෆ්ලෝ එක කියන එක ඔයගොල්ලෝ දන්නවා, ප්‍රෙෂර් ෆ්ලෝ එකක් දන්නවා, ලීකේජ් ෆ්ලෝ එකක් දන්නවා. කොහොමද දැන් මේක අඩු කරන්නේ? ඒතර ලීකේජ් ෆ්ලෝ එක ඇති වෙන්නේ මෙන්න මේ තියෙන ස්පේස් එකේ හින්දා. මොකක්ද එහෙනම් කරන්න ඕනේ? Nobody wants to give answer නේද? Then I will ask some. Navoda Navoda. I don't know, Mr. or Mrs. Miss Navoda or Navoda. HMC.
Yes, sir.
මොකද්ද දැන් මෙතන ලීකේජ් ෆ්ලෝ එක කොහොමද නවත්තන්නේ? ඒක අත්‍තරම පාඩුවක් නේ අපිට. Any idea? From Janaka space එක අඩු කරන්න, right? To reduce the space. How to reduce that space? Space එක අඩු කරන්න පුළුවන්, right? ඒකත් හරි. ස්පේස් එක අඩු කරොත් කොහොමද අපි මේ ස්ක්‍රූ එක බැරල් එක ඇතුලට දාගන්නේ? නේද? තව උත්තරයක් මට දෙන්න කවුරු? So you are from UNIVOTECH, you should have answers. තුවක්කුවේ බටේ දැකලා තියෙනවද කවුරු හරි? Viranga 43, number 43. Viranga. Right. ඔන්න දැන් කවුරුත් answers නැහැ වගේ පේන නිසා මම කියන්නම්. අපිට පුළුවන් මේ බැරල් එක ගෲ කරන්න. දැන් ස්ක්‍රූ එක shaft එකනේ අපි කියන්නේ මොනවද මේක ස්ක්‍රූ එක. ඔයගොල්ලෝ දන්නවා ස්ක්‍රූ කියන්නේ what is the meaning of the screw and shape. So we are going to glue this barrel. අපි barrel එකේ ඇතුල් පැත්තේ glue එකක් හාරනවා, screw එකක් හාරනවා. Then we can avoid that leakage flow. Right? So therefore you can see glued barrels in some high pressure screw extruders. Right? Right? Okay. Then as we discussed the melting and dough forming will occur. Powder particles convert into a fluid or dough due to the hydration. Hydration means absorbing water or any liquid. Sorry, absorb water and it will convert into hydration. Adequate amount of water and or heat is necessary in this section. So we have to provide adequate amount of heat and also water. Right? Ushnatya is very important. Starch gelatinization, swelling due to moisture uptake. You know what happened when we add starch and water, then volume should be increase due to the swelling action. Increase the viscosity of the dough. Right? Wheat flour ටිකක් වතුරට දාලා කරකවන වගේ හිතන්න what happened here. උණු වතුර ටිකක් දැම්මම මොකද වෙන්නේ? Right? It's increase the viscosity. Temperature, moisture content, pressure and particle size are important. Right? Temperature, moisture content, all these things are very important in dough forming. Dough එක කියන්නේ අපි ඔයගොල්ලෝ දන්නවනේ අපි රොටි හදද්දී හදන්නේ අර ගෙඩියක් වගේ එකක්. All mix කරලා we call it as dough. When the extruder barrel consists low or inadequate amount of water, there should be a heating facility to convert the raw materials into a dough. If we don't have water, then we have to provide temperature to melt it down. Right? All these things are very important. So please note down the important things. ඔයගොල්ලෝ මම කියන ඔක්කොම ලියන්න ඕන වැදගත් ඒවා ලියා ගන්න. මොකද මම question paper එකට මේ theory මම අහන්නේ නැහැ. So you have to give think and write the answers. So hope all these things are clear. Right? Then what happened with high temperature, with moisture? What happened to the dough? It will gelatinize and increase the viscosity up to some temperature, up to some extent. Then we can improve it, increase it further. Then viscosity will be decreased due to the breakdown of these swollen starch granules. And again, Newtonian and non-Newtonian fluids are very important. I think you all know these two terms. You might understood and you have heard these words under food physics or fluid mechanics, like any other course material, course unit. Anyway, I will briefly explain what are the Newtonian and non-Newtonian fluids. ඔගොල්ලෝ මේක කරලා තියෙනවද මොන හරි ඉන්නේ subjects? Food physics තියෙනවද ඔයගොල්ලන්ට?
Yes, sir.
You know what are the Newtonian and non-Newtonian? Yes or no? Shall we discuss or you know? උත්තරයක් ගන්න ඩල්ලි මට මේක discuss කරන්න එක නේ. Right, okay. Then for Newtonian fluids, viscosity remains constant. Right? For Newtonian liquids, it means these liquids follow the Newton's law. Right? Viscosity remains constant for Newtonian fluids when apply shear force at a constant temperature. These fluids have a linear relationship between viscosity and shear stress. So it's easy, and some examples are also there. When it comes to non-Newtonian fluids, viscosity will be changed with the shear force. Right? එතකොට ඔයගොල්ලෝ මොනවා හරි හිතන්න මේ දෙයක් අපි as we discussed wheat flour and hot water, when we increase the stirring speed, then what happened? The viscosity will be increased. And suppose we are going to mix it sugar and water, hot water, then again the same thing will happen. And there are 4 types of non-Newtonian fluids: dilatant, pseudoplastic, rheoplastic, and thixotrophic. So there are 4 types. The first one, viscosity increase with the shear. I will show you some examples. When it comes to pseudoplastic, viscosity decrease with the when we are shearing. ඔයගොල්ලෝ ගෙදර තියෙන ජෑම් බෝතලේ හොරාට හැන්දක් දාලා කරකවලා බලන්න මොකද වෙන්නේ කියලා. shear force එකක් දීලා. ගෙදර තියෙන sauce එක හරි ජෑම් බෝතලේ හරි නිකන් හැඳිමිටක් දාලා ටිකක් වේගයෙන් කරකවලා බලන්න මොකද වෙන්නේ කියලා viscosity එකට. Right? You can do that one. So there are two other terms, rheopectic. It is the same thing will happen, but it is time dependent, right? It means viscosity will be increased with the shear. In thixotropic, viscosity will be decreased with the temperature, with the shear force, but temperature time is very important, right? You can find some examples. Here you can see the common picture I have obtained from the internet, and you can see the reference here. The same mixture, corn starch and water, right? And you can see what they are doing and what happened to the texture, right? You can read and understand this one. I'm not going to explain. So melt conveying, now we have discussed the temperature has been increased, moisture is there, pressure is there, solid bed is there. So start melting. Now dough is there. Viscosity has been increased, right? Viscosity of the fluid may change with the temperature and time. Also the viscosity depend on the oil content, moisture content, structure, chemical changes of the food. So understood neither. These things are important. දැන් අපි කතා කරන්නේ එක්ස්ට්‍රූඩ් එකකට ටෙම්පරේචර් එක දීලා ඔක්කොම පිරලා තියෙන දැන් ඒක වැඩ කරනවා ඒක නිසා මේ කාරණා very important. ඔයගොල්ලෝ දන්නවා ගෙදර රොටි හදනකොට අපි ඩෝ එකක් හදනවානේ නේ රොටියක්වත් හදපුවා ඉන්නවනේ මෙතන අපි විනෝදෙට හරි ඒ ඩෝ එක හදනකොට අපි wheat flour use කරනවා පොල් use කරනවා salt water හරි salt හරි use කරනවා ඒක වතුර ටික ටික දාලා අපි මේක අරනවානේ ටික ටික දාලා මේක ඩෝ එක අපි ෆෝම් කරනවා වතුර වැඩි වුණොත් මොකද වෙන්නේ රොටි ගන්න වෙන්නේ නැහැ එකකින් පෝස්ටර් ගන්න තමයි වෙන්නේ right වතුර අඩු වුණොත් ඩෝ එක හදා ගන්න බෑ අපි කියනවා පදමට අපි රොටිය හදා ගන්න කියන අතේ ගෑවෙන්නේ නැති ගන්නට හදන්න ඕනේ so it means the proper proportions are very important adequate amount of moisture oil all these things are important ඉතින් අපි ඔයගොල්ලෝ ගෙදර මේක කරලා බලන්න පුළුවන් පොල් වැඩි පොල් දැම්මම මොකද වෙන්නේ පොල් අඩු කරාම මොකද වෙන්නේ so those are the experiments you have to do before starting any complex processes. අපි ගෙදර අඩු ගානේ සීනි ටිකක් දාලා එක එක උෂ්ණත්වයට රත් කරලා බලන්නේ නැහැ නේ. So the different reactions are there. The color, texture, all these things will be the different reactions. Right? Therefore, mixing time, temperature, pressure are very important. After the melt conveying, the fluid transferred to the high pressure zone just before drying. So you know high pressure zone we discussed it is dye, right? Before the dye, just before the dye. Thereafter the final stage, product formation stage. So we have discussed all these stage. Now the dough is okay. It is close to the dye, right? High pressure zone. So let's imagine that we are going to open the entire dough. Sorry, dye. අපි dye එක ගලවනවා. මොකද වෙන්නේ විතර ප්‍රෙෂර් එකට? මට ඒකටත් උත්තරයක් දෙන්නකෝ. We are going to remove the dye. Then what happened to the pressure? Aldia. Sakuntala. MR and Sakuntala?
Yes, sir.
dye එක ගලවන්න යනවා. මොකද වෙන්නේ ප්‍රෙෂර් එකට? Reduce, right? Pressure will be reduced. So it means what happened when the volume extruded. When we open the die, pressure will be reduced and the volume will be increased. So it means volume and the pressure are opposite. Graph you also can see x-axis represent the pressure, y-axis represent the Q. Q means the volume extruded. And when we close the die, you know the pressure is very high. So P max is there. When we open the die, I will open fully, pressure එක බිඳුව වෙනවා. අඩු වෙනවා. Atmospheric pressure එක එනවා. එතකොට pressure එක අඩුම වෙනවා. අපි die එක ඇරියොත් when we open the die Q max කියන්නේ වැඩි ප්‍රමාණයක් output එක එනවා. අපි die එක close කරොත් output එක අඩු වෙනවා. I think it is very easily you can understand. This is a graph. These are the relationship in between these three factors, and we call this point as operating point. In selecting operating point, you can see the equation. Die characteristic, it's very important. අපිට එතකොට මේ හැම එකටම මේ graph එක ඇඳලා මේ අපිට ඕන විදිහට මේක හොයාගන්න බෑ. There are some equations and mathematical calculations to identify the. So you just remember there is a term called operating point. Pressure, Q, and die shape, all these things are important for operating point. Right? So today we have discussed very important things in extrusion. Now you can do assignment, I think. So my assignments are only one page. Right? Mage assignment එක පිටුවයි තියෙන්නේ. Presentation කරනවා slide 3යි තියෙන්නේ. ඔයගොල්ලෝ කැමති presentation එකකට slide මොනවයි submit කරන්නද? Let's do we have to do assignment now. So two options are there. I can arrange a presentation session for 1-2 day. 1 or 2 day, and I will give you 3 weeks or 4 weeks. I can give you no matter. Or if not, you have to submit an assignment, Word or PDF document. So what is the most preferred one? Assignment. Right. So that's your suggestion. And then ඔයගොල්ලෝ ගොඩක් කැමති ඇති assignment එකට කවුරුත් කියන්න දෙන්න මම එක මාසයක ආපු හින්දා ඒක පිළිගන්නවා. එතකොට මගේ suggestion එකක් තියෙනවා. Assignment එක කළා ඔයගොල්ලෝ group presentation එකක් කරන්නත් ඕනේ. Right? You have to do a group presentation. The assignment is about extruders used in food industry. Right? This is assignment. I will share the assignment guidelines. මගේ හැම assignment එකටම මම guidelines එවනවා. Font size එක, page size, everything you have to consider. එතකොට අර මේ ඉස්කෝලේ කාලේ ඔයගොල්ලෝ project එක හදුවා වගේ මල් මාලා දාලා එහෙම හදන්න බෑ. There are some scientific writing rules and regulations. You have to follow these things. ඒක මම guideline එකක් ඔයගොල්ලෝගේ batch trip වලට share කරන්නම්. එතකොට අපි assignment එකක් කරනවා මොනවද food extruders පාවිච්චි කරන්න කියලා industry එකේ. So the assignment is about the extruders used in food industry, and you can imagine you are going to develop new food product, and based on that you can determine your extruder, and the things should be included. I will share. මොනවද එන්න ඕන කාරණා කියලා මම share කරන්නම් guidelines වල. ඊට පස්සේ අපි group presentation එකකුත් කරමු. අපි will have around 9 or 10 groups. Today we have 45, so 5 members for a group. Then there are 9 groups. So we'll have 3-minute presentations. So you will have only 3 minutes. You have 3 slides, so you have to present the thing, right? So today we have discussed some very important things. Right? Extruder die, how it's important, what are the die characteristics, right? What are the terms, important terms, and specific designs also discussed. You have homework to find farinaceous and proteinaceous food product. and there are different shapes of dies are available. In this shape, and there are common some other, as I explained, some other dies are available. So two major functions of the die, and in designing a material for the die and in developing die, there are some important factors to be considered. So you know these things now, right? And how to select die, and we have discussed an exercise also. So melt conveying, how to develop the dough, right? And feed throat problem, bridging problem. You know what is the feed throat problem, and you know why we are using small particles in food extrusion, right? And what are the difference in between plug flow, solid bed, and also pressure flow and leakage, how to avoid leakage flow. So these things we have discussed today, and viscosity changes, and Newtonian and non-Newtonian fluids. So we have discussed, and melt convey and operating point, extruder operating point. So these things we have discussed today, and the next week, next 2-3 lectures, I will discuss some extruder details. Then we have to discuss some other, how to select raw materials, quality assurance of food extrusion. All these things I'm going to discuss with you, right? So if you need any change or time or the method of conducting of these lectures, you can propose, no worries, right? Any ප්‍රශ්න තියෙනවද? Do you have any questions? ප්‍රශ්න නැහැ. Right. එහෙනම් next week එනකොට මේ ටික හොඳට බලාගෙන ඉන්න, right? So and think on the assignment also. So seems there are no more questions, so we can wind up the session now. If you have further questions, so you can contact me. Normally I am answering the phone. If not, please text me, or you can send an email, right? So thank you very much for being with this lecture and listening to the lecture carefully. So I hope you have get something new today. So please open your third eye, try to open your third eye, and imagine new thing always. Try to do new things. So thank you very much for being with us today. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.